In previous videos, we talked about intersections and unions and complements, and now we are going to continue moving into set properties and just describe them a little bit more. Okay, so first thing that we'll talk a little bit about is how A union B is the same thing as B union A, and this is called the commutative law. So if we just think about A union B, what is it by definition? It's everything that's in A and or in B. So anything that's shaded here is in A union B. And similarly, if we draw out B union A, then we would shade in B, and we would shade in A, and we see that we'd have the exact same thing shaded in for A union B as we would for B union A. So we can see how A union B and B union A are the same thing. Let's do the same thing with intersections. So if we think about A intersect B, here's A, and here's B. And so A intersect B is anything that's shaded in twice. So this is the only part that's shaded in twice, so this is A intersect B. And now if we do the exact same thing with B intersect A, let's shade in B, and shade in A. And again, we're looking for anything that's shaded in twice, and so we would end up with the exact same bit. So A intersect B and B intersect A are the same thing. All right, next up, let's look at this next property. So let's draw A union B, union C. So here's A union B. So we just shade in everything that's in A, everything that's in B. And now let's add in C so that we have A union B, union C. So we can see here's A union B union C, and if we drew the same thing, but first looked at B union C, then we'd have here's B union C, and here would be A union B union C. So we'd have the exact same thing. So A union B union C is the same thing as A union B union C. Next up, we look at the same thing but with intersections. So if we're looking for A intersect B intersect C, let's first start with this inner bit, B intersect C. B intersect C is that blue shaded area. So let's see what in that blue shaded area is also an A. This part right here is also an A. So that pink part that we've drawn is A intersect B intersect C. And similarly, if we drew the exact same thing, and instead we did I'll write this for more space, A intersect B intersect C. That's the same thing we'll see as next. Let's do A intersect B intersect C. So hey, here is A intersect B, and let's look for the part that's also in C, and that is this pink bit right there. So we can see these two expressions are the same. All right, so we have seen how A intersect B intersect C is the same thing as A intersect B, then intersected with C. Next, let's look at A intersect, or rather A union B intersect C. Oops. So first let's find B intersect C. B intersect C is this part right here. Now let's add on A so that we have A union this shaded bit here. So we just shade in all of A to go with what we have shaded already. All right, now let's move on to this stuff on the right side and we'll draw it in here. So let's find A union B. So to find that, we shade in all of A and we shade in all of B. And then, so we've done in blue this part here. Let's do this part in green, A union C. So A union C is shade in all of A, shade in all of C. And now let's find what parts are shaded with both blue and with green, because we want to find the intersection of these two sets. So what parts are shaded with both blue and green? So we can see this is shaded with both blue and green. This is shaded with both blue and green. And also B intersect C is shaded with both. So we can see here that A union, the quantity B intersect C, is the same thing as A union B intersected with A union C. All right, similarly, let's look at A intersect B union C. So first let's find B union C. B union C is that blue shaded area. Now let's find A intersect the blue shaded area. A intersect the blue shaded area is this right here. So what I'm drawing in pink is A intersect the blue shaded area. Next up, let's do A intersect B in blue. So A intersect B is here. And then let's do A intersect C in purple. And now we want to find the union of those two. So we are just looking for anything that's shaded in, and it is this bit here, which I am covering with pink. All right. Finally, let's get into something called DeMorgan's laws. So for DeMorgan's laws, we need to have two sets, A and B. So here's A, here's B. And DeMorgan's laws say that A union B complement is the same thing as A intersect A complement intersect B complement. So let's draw this out to see how that goes. Okay, over here we're going to do this left part. So A union B is the purple shaded area. And then we want A union B complement. So we want everything that's not in that shaded area. So this is, here's A union B. And so then A union B complement is everything that's not in the blue shaded area. So here is A union B complement. Now let's look at A complement intersect B complement. A complement is everything not in A and B complement is everything not in B. And now we want to find the intersection of the green with the purple. So in other words, we want to find all the bits that are shaded with both green and purple. And so cleaning it up, it looks like all of the stuff outside of the two circles. And so this here, we have drawn A complement intersect B complement. And so we can see these two sets are equal. So this here is one of DeMorgan's laws, and then the other one is A intersect B complement is the same thing as A complement union B complement. So let's go ahead and draw this one out. So here's A, here's B. Let's start with A intersect B complement. We know that A intersect B, we'll draw this with really tiny lines. We know that A intersect B is this part right here. And we want the complement of that. So we want everything in this green rectangle that is not shaded with blue. So A intersect B complement is everything that I'm about to shade in pink. Okay, so everything there in pink is A intersect B complement. Now let's look at A complement union B complement. So here's A, here's B. A complement is everything not in A. And B complement is everything not in B. And we want A complement union B complement, so let's just take any part that is shaded in at all. So we end up with everything except for this middle bit. Okay, so now we have shown that A intersect B complement is the same thing as the union of A complement and B complement. So this is one piece of DeMorgan's laws, and this is the other.